So welcome to 2021, question A-4. It is an intersecting solids or interpenetration question. The image below shows a modern house design which is based on intersecting prisms. The drawing shows the plan and incomplete elevation of a similar structure which includes a pentagonal prism intersecting a truncated rectangular prism. So we have a rectangular prism here and we have a pentagonal prism here. Okay, and there's nothing to say that it's a irregular, regular pentagonal prism. So we can't take that for granted. So pictorial view and intersecting solids is also given. Complete the elevation showing all of the lines of interpenetration. Okay, so we'll start off by going through a checklist of can we use the limits method for anything here, and I would say we can. So some of the points have already been done for me. Okay, I can see my hidden detail line, that's representing the ground, okay, or where the pentagonal prism hits the ground. Okay, and we've also got this edge here, and it's located. So we actually do identical thing on this side. Project up, and let me just extend that edge. Okay, so that is 2 points done using the limits method. And this front edge is actually going to be heavy all the way down. It's not cutting into anything. Okay. After that, we have more limits we could use, so I can see the turning point here and here on that edge. Project that across. So they're going to be hidden detail lines running as far as there. So those seem to be all the points I can find using the limits method. Now, next up, so we have limits. Okay, then we've elements is the next method, and we've sections. Okay, so elements, let's see, I could create a straight line element. If you imagine for some of these points here, if you imagine I created a straight line element, maybe running along from that point until I hit the edge, because that will find me this a point along the edge, and I can project that down and across. Yeah, so that's what I'll do. Okay, straight line elements to find some of those points. So I'll start here with this one, comes to there, and I can project that straight up onto my surface, onto my edge. Okay, and that can come across to match up at this point, or with this edge. Okay, next another straight line element for here, resting on my plane, on that top surface. I can project that up onto the surface there, and carry that back across. So straight line element, finding that point for me there. Okay, and then at the back, I'll do the same thing, straight line element up onto that back surface and project across and up, and that will be a hidden detail line continued on down to there. Okay, so what we need to do now is work out hidden detail lines and heavy lines, connecting everything up. So at the front surface here, right, I know I'm going to have straight line edges joining up. Okay, and then we're going to be going, traveling back up along from that point that I've found, travelling back up to the top edge. You can follow that top edge there. So that's up to this point. So hidden detail line running back. Okay, and then we'll continue down on the far side of that, so travelling down then to that point that I'd found, and that will also be in hidden detail. Okay, and that will travel back to this point, hidden detail line again, and then come back around again. Okay, so I think that is everything on that. Oh, one last bit of hidden detail. So we've got this back edge started hidden detail, so we'll continue that over, and then it stops, so it actually will continue on all the way in behind. So, okay, so that's all our hidden detail lines, I believe. So you can tick that off. Then determine the true shape of surface A. So here's surface A. Okay, surface A is actually down here in plan. Right. So at the minute we don't have a true height for it. Okay, a true length of one edge. So what we're going to need to do is, I'll rub out my little notes here, is we're going to need to find an edge view of that surface first of all. So I have a true length of the base here and a true length of that edge. Okay, so I'm going to look out along and see those true lengths as a point view. And if I see them as a point view, then I can I'll obtain an edge view of the entire surface. So XY line here, project out. Okay, so this is X, Y, X1, Y1. Okay, we're projecting from plan, creating an auxiliary elevation, so the heights come from an elevation. These two edges, the hidden detail lines, they actually represent the bottom here. So my height then is going to be stepping up for those edges, and now I have an edge view of that plane, or of that surface A. So our options after that then is I could take a second auxiliary looking perpendicular to it, or I can rotate it back down. So that's actually what I'm going to do. I'm going to rotate this surface back down. Okay, and project that there. That stays where it is. So we're rotating about this line, or that edge view, that point. Okay, so that's been rotated back. And just for clarity then, I'm going to use a different colour just to highlight this true shape. True shape A. Okay, so that is the second part there of that question. So we've got find a true shape of something, and also our interpenetration question there on A4 2021.